All right, hello everybody. Happy Wednesday. Happy Would You Rather Wednesday. I'm wondering what you would rather do, have Thanksgiving at my house or have me come to your house. We'll have to talk on Thursday. Today we're going to do solving systems using elimination. This is our third method to solve systems. What my plan is I am going to guide you through how to do that. So I'm going to lead you through some notes today. And then at the end, you are going to be asked to do this exit slip and turn it into the sub. This will be how I take attendance. And the exit slip will have one review problem of graphing, which we've already done, one review problem of substitution, and then what we did today, which is elimination. Okay, so that is my expectation today. Your warm-up is solving the system by substitution. My hope is that you will turn off or pause the video and try it on your own and then check your answer. If you do not get the same answer as me, my advice would be then to watch the video of how I solved it. Here we go, solve the system by substitution. So again, when I do substitution, I like to write my equations side by side, and I like to identify the equation that has the variable alone. The equation that has the variable alone is this one over here, x equals negative y plus 5. So I'm going to replace the x with negative y plus 5. So I have 2 times negative y plus 5 plus 3y equals 12. And now I'm going to go ahead and I'm going to take my time, do my algebra skills, distribute my 2. Then I'm going to combine like terms. I have a negative 2y and a positive 3y. That would be a y plus 10 equals 12. Subtract 10. I'm getting y to be 2. Again, as I kind of said in class, I like my way of coming full circle. X equals negative 2 plus 5. I'm getting x to be 3. So my solution is 3, 2. These two lines would intersect at the point 3, 2. That is solving a system by substitution. As stated today we're going to use our third method, which is called elimination. So the first thing I want you to do is just take a moment and notice something. What do you notice about the following linear systems that we will solve using elimination? So really, what do you notice about those 4 systems? The first thing I do hope that you notice is that all of those systems, that both equations, not one, but both equations are in fact in standard form. Again, that means that the x and y are on the same side. Notice how both equations that happens. The other thing I was hoping you notice is that you were looking for what we call opposites. In other words, the goal of elimination is to literally do that, to eliminate one of our variables. And the easiest way for us to do that is to create opposites. Opposites are numbers that will create 0. In other words, an example of opposites would be 10 and negative 10. Those are opposites. Those two numbers, when I add them together, make 0. So if I take a moment and I look at all these, I notice that this first system, that negative x and x are opposites. And so what we're going to do today, which I'm not going to do all of it right now, we're just practicing, is I notice they're both in standard form. I have opposites. So what we'll end up doing is we'll add down. When we add down, we only will have one variable, and then we can solve that for y and then go back and solve for x. So that's how we're going to finish the problem. But for right now, I just want you to notice that how we could use elimination. Again, this next problem, I notice that they're both in standard form, and I do notice that I have opposites. So again, I would add down, and when I do that, I only have one variable, and then I'm able to solve and go to work. Again, we will finish these problems in a little bit, but right now we're just practicing that. In this next one, they're both in standard form, but this time your opposites are in the y spot. Again, negative 9 plus 9 makes 0. And if I add down, I would end up with x equals 8, and then I would solve for y. And then finally, last but not least, again, they're both in standard form. These are opposites. So when I add down, I get 11x equals 22, and then I could solve for x. So all I was trying to get you to see there is what opposites are and this idea of adding down. We're not actually finishing those problems as of right now. Now, this section says what happens now. So I want you to take a moment and notice. I notice that all of my equations are in fact in standard form. However, I don't notice any opposites. When I don't have opposites, I'm going to have to create opposites. And the way I create opposites is I create a common multiple, a common number that both numbers multiply to. This will help me create opposites. So in other words, if I look here, I notice that this is a positive x and this is a positive x. So those are both 1s, but they're not opposites. The opposite of 1 is -1. So what I could do is I could multiply one of those equations by a -1. Doesn't matter which one, I'll do the top one. If I multiply the top equation by -1, I end up with -x plus y, because I'm distributing, and then I also do it to the other side, equals +5. And then this one doesn't change, so I'm going to leave it exactly the way it is. X minus 5y equals -9. And by doing that, I created opposites, which means then when I add down, I can solve for y. The next one, again, I'm going to do more work with that later. I'm just trying to go through creating opposites. We're not actually finishing these problems. This next one, I look, they're both in standard form, but I don't have opposites. I could create opposites here. I know that 6 and 3 have a common multiple. 6 and 3 both multiply to 6. They also multiply to 18. That's another option, but I would probably try and go with the smallest. So, well, that one's already a 6. If I multiply this bottom equation by -2, I could create an opposite because the top equation doesn't change. But the bottom equation now would be -6x. I got to do it to everyone. +4y and +14. And so now I have created opposites. And when I create opposites and add down, I end up with 7y equals 26. And then I would solve for y and do more math. Again, right now I'm just practicing creating opposites. All right, it doesn't matter which one I create opposites with either. Again, this next one, why don't we try eliminating the y's? I look, they're both in standard form. I don't have opposites. So this time, I don't know, I'm just going to attack this one. I want to make those numbers opposites. They are opposite signs, but they're not opposite numbers. Again, I find a common multiple. What do 5 and 2 both multiply to? They both multiply to 10. So I'm going to multiply this top equation by 2 and this bottom equation by 5 because now I could make them be opposites. And if I do it, I can see 2 times 4 is 8x, 2 times 5 is 10y, 2 times 2 is 4. This one would be 15x minus 10y, and that would be equals 100 if I distribute all those. And again, I know I did well because these are opposites. And so when I add down, that's 100. I get 104, etc. And then I solve from there, which again is what we're going to be practicing in a little bit. So all I wanted to do right now was just practice finding opposites, okay? My hope is that that makes sense. Elimination means that we want to stack them on top of each other, create opposites, and then add down. So here we go. This one says to solve by elimination, which means I want to eliminate. So the first thing I do is I look, 4 and 4 are not opposites, 2 and 8 are not opposites. However, I could make 4 and 4 become opposites if one of those was a negative. So I'm going to go ahead and multiply that top equation by -1, which would now make it -4x, -2y, and -12. The bottom equation, I don't need to change, so I'm going to leave it alone. I'm just going to slide it over. And now I have created opposites. So when I add down, I end up with 6y equals -36. Divide by 6, y equals -6. So now I have my y, and now I need to find my x, which means I just need to take this y and I can sub it into either one of those equations. It doesn't matter. I typically pick the one that I find a little bit easier to work with. I think that top one is a little bit easier to work with. There's less negatives in there. And all I do is I substitute that in. So now I have 4x plus 2 times -6 equals 12. And now I use my algebra skills from Unit 1. Add 12, 4x equals 24, divide by 4, x equals 6. So my solution is 6, -6. If I were to graph those two lines, that would be the point that they intersect at. Next, all right, I need to create opposites. So again, they're both in standard form. I happen to notice that that's a 3 and that's a -1. 3 and -1 can both multiply to 3. So that's already a 3. So I'm going to multiply this bottom one by a 3. The top equation does not change. The bottom equation now is a -3x. 3 times 2 is a positive 6y, and 3 times 19 is -57. Again, I know I did well because these are opposites. One was already a negative, so I just needed to do that little piece. If I add down, I'm getting 10y equals -80. Divide by 10, y equals -8. And now I go complete full circle, and I'm going to finish my problem by subbing it into one of my equations. I'm going to pick the top one. Why? I don't know. There's less negatives, maybe. 3x plus 4y equals -23. I'm going to sub that in for y. So 3x plus 4 times -8 is -23. 3x. I got -32 equals -23. Add 32, 3x equals 9. Divide by 3, x equals 3. So my solution is 3, -8. That is the point where those two lines would intersect. Finally, last but not least, solve by elimination. Step 1, they're in standard form. Step 2, create opposites. I can create opposites in either spot. This time, I don't know, let's do it in the y spot just to show you it doesn't matter. I notice that these are opposite signs already. I need these to be opposite numbers. So again, I find a common multiple. What do 3 and 5 both multiply to? 15. So I'm going to multiply the top equation by 5 and the bottom equation by 3, which will create opposites. So if I do the top equation, I end up with 10x plus 15y equals 55. If I do the bottom equation, I would end up with 9x minus 15y equals, just making sure, -93. Again, I know I did well because these numbers are opposites, so they eliminate. So when I add down, I end up with 19x equals 55 plus -93 is -38. Divide by 19, x equals -2. Once I get my x, I can sub it in. I'm going to pick the top equation, less negatives again. I'm going to sub that in. 2 times -2 plus 3y equals 11. -4 plus 3y equals 11. Add 4, 3y equals 15. Divide by 3, y equals 5. So I'm getting -2, 5. All right, so that is today's lesson on elimination. Again, what is elimination? Elimination is when both equations are in standard form and we create opposites in order to eliminate a variable. Sometimes we have opposites, Sometimes we need to create opposites. If we need to create opposites, we find a common multiple, a common number that both numbers multiply to, and then we add down. So your next step is I need you to rip off this exit slip, Unit 4, Day 5. I ask that you put your name on it, and you do problems 1, 2, and 3. You turn this in. When you are done, you can get out your homework and work on your homework assignments. That pretty much is the majority of the material for Unit 4 before our first formative. So now would be a good time to start practicing. And then again, make sure you turn this in because this is how I'm holding you accountable for today. I will see you all tomorrow. Tomorrow is elimination, more practice. If you need more help, please come with questions. I'll see you tomorrow.